Good afternoon. Thank you for joining us. This is Managing Lifecycle at the Edge. We're doing something a little bit different here. We have the video feed kind of showing, me in my office, in my space with the hardware, as well as the sharing of the slides and demos as we go along. So bear with us a little bit as we try this new format out to be a little bit more interactive and give more of that in-person feel, like if I was at a trade show or at a booth or visiting in your office kind of thing. So hopefully everybody on the call knows Now Micro, but we were founded in 1993. We're based in St. Paul, Minnesota, and we're a Dell, HP, Lenovo, Intel, and Microsoft partner, among others. Hold some contracts and focus on a lot of Minnesota state government education business, as well as IoT and edge computing. Our mission is to help our customers navigate technology to the edge and beyond, with purpose-built hardware and manufacturing services. I'll sort of draw that out as we talk about edge computing, where we see that vision, where it's going, and then sprinkling through sort of what a platform means for edge computing, what it means to you, and what you can build on top of it. I have some real-world examples of things that we built upon edge computing, and then some sort of vague things I've seen other people do as well. And at the end, we'll have some time for questions. I believe, depending on whether or not the chat window showed up with the questions, will they be addressing them over email or live in the webinar today. So we'll kind of play that by ear. I've got some themes for you today. The themes are sort of these underlying threads of what we're doing, what we're talking about, and what we're trying to accomplish, right? So I think number one is remote support. I'll hit upon this over and over again, but I think, recent events and have sort of accelerated the need to be able to have remote touchless type support. Automation also plays into that. Having automation instead of throwing bugs at things is something that a lot of organizations are looking at, and also lets you sort of drive efficiency and scale upward. A platform is another theme, another concept of the platform letting us scale, a place for people to build things, build on top of, build new ideas, and adapt to changing conditions, as well as being feature facing. As we talk about hardware, especially edge hardware, I think as you look at what you're buying today, you probably don't know the use cases that you'll be pushed into or want to go to in the next 3 to 5 years. If you're talking about a 3 to 5 year life cycle on a device, we cannot fully expect exactly what's going to be in the future. And having that room and adaptability and that platform, the automation, the support to be able to support those future facing ideas is going to be more and more important, as you don't want to go visit, tear out, rip out all the hardware you have in the field. We're sort of crisscrossing this with lifecycle phases. So we see the lifecycle of a device in 5 stages that people are typically following. One would be procurement, just getting the hardware, sending the PO, securing it, right? Imaging and provisioning, installation, right? So getting it to where it needs to go, getting it, stood up, plugged in, and ready and working like it needs to as part of the deploy phase. And then moving on to it's installed, it's living. How do we manage it over time? How do we make sure that it's secure, up to date, that it can support new things, that we know if it's gone or not, where it is, so on and so forth. And then finally retiring. When we get to the end of the asset's life cycle, do we know how many we have to remove? Do we know how many are maybe unused or got disconnected over the period of time? How many do we need to replace this with? Do we need more computation than we have currently? Are there new use cases we need to be able to handle? It's an important part to reflect backwards on a life cycle of a device at the end to understand how to move forward if this is a continuous process. So starting with the platform, I think platforms are, it sounds cliched, right? Because we're talking about, oh, you build a platform and everybody uses it and it's great. And But I think we've seen some platforms that have really made a difference in how we use compute over time, right? So, take the iPhone and the Android, smartphones in general, right? These stores, these platforms that you can build against mean that there's all these use cases for a smartphone that didn't exist when they first came out. I bought an iPhone opening weekend, 2006, moving from Windows Phone. And I thought it was the greatest thing ever because it had a web browser. I'm like, that's so great. And eventually apps came, and I realized that I use my phone completely differently than I did 15 years ago or 14 years ago when the iPhone came out, right? I don't take phone calls. I don't answer my phone. I use apps all the time. I connect to smart devices and things inside my house, my thermostat, my car. I unlock my doors with my car, with my phone, right? So how we use the platform now is significantly different than how we started with it, right? So we're inviting that innovation over time. We're creating a platform that lets people do more that we haven't envisioned during the genesis of that platform. That allows us to just enable, right? So we're enabling use cases past that immediate business case. My first business case for buying that smartphone was about, it has a web browser and I can, hit web pages on it and do things I wasn't able to do on a Windows phone. And now, that enabled a lot more cases past that bring infinite more value than they did at that point in time. So, I don't think it is cliche when we're talking about edge computing, when we talk about a platform being important. As we deploy a platform, we deploy a piece of hardware in the field that has a little bit of overhead, some room, maybe it's running a container workload. When the next workload or ask from the business side comes, it's not about ripping and replacing that hardware with something faster necessarily. It's not about it's not about how do we do this, how do we make this happen, all these costs of hardware. It's about, we have a platform there, let's deploy it to that platform. I've been to a few IoT conferences last year. We saw a lot of retailers using edge compute, whether it be like Intel NUC-like devices or even servers to sort of perform a particular function. Let's take temperature measurement. If you're looking at food safety, you might have a clear business case for putting sensors and temper measurement out in the field. But now that you have that hardware, measurement of temperature does not take that long. It is not very CPU intensive necessarily. Even combining and correlating the data and sending it up to the cloud to report somewhere just is not utilizing the fullness of that hardware probably. Well, now we can build something else on top of this. Can we do things around energy management for the entire facility? Can we read POS analytics and do prediction and help fuel how we schedule our workforce? Can we count people? Because maybe I have a capacity limit that's severely smaller than it used to be, and I need to be able to count the people in the location. That platform enables those future things without actually having to think about, well, how do I also pay for the hardware for this? These are incremental benefits that are built upon an initial purchase. So when I look at a platform, I think we got some requirements, right? So number one thing we want to look for is blocks of flexibility. I usually use the example of Lego blocks. You want to build blocks that can be remixed, combined to meet a particular business's use case. So not everybody has the same edge computing needs. Some people might be vision focused or AI focused. Some people might be sensor focused. It might be about customer communication. It might be about employee communication. All these things probably need a little bit different edge computing platform, right? On a software side in particular. They might all use, similar hardware in the end, but we do need some flexibility, right? And we need some differing form factors, computation ability, maybe even AI accelerators, FPGA type accelerators as well to sort of meet those requirements. We also need reliable hardware. I think now more than ever, there was a use case that, very good statistics that truck rolls are expensive, right? Sending a person out to a location to fix a piece of hardware is expensive. Now we also have a number of ethical questions wrapped around it, where do I want to send somebody out? Is there somebody there that could already do the work? Am I able to actually do that travel and get there? Can I reliably get that hardware back here through our existing transport system? Reliable hardware is more important than it ever has been. I talked about future-facing hardware. I think that's still super important. buying hardware that supports 99%, is at 99% of capacity during deployment is a case for not making a platform, right? If I have, for example, 50% capacity, now I have a number of things that I can enable in the future, use cases I have not envisioned, use cases my business hasn't envisioned. It's important to have that overhead freedom to be able to, sort of face the future and not have to immediately rip the hardware out maybe in 3 years when it's grossly outpaced by new things. We also need to be adaptable. That sort of weaves into these other things, blocks of flexibility, reliable hardware, future-facing hardware. We need to be adaptable. Travel has changed. How much we actually want to touch devices or be near devices other people have been near has changed. And we still have that continuing theme of infrastructure as code. If we look at the evolution of DevOps and do, like, for example, container-based workloads, we're now seeing more and more applications and their associated infrastructure being code itself, being change controlled, testable, deployable. And that's, builds upon, software-defined networking and other, virtualization, other technologies throughout the years. It's the next step. And it's definitely something that we need to be able to adapt towards as these new use cases emerge. So in that context, I'm going to go back to the sort of procure, deploy, manage stuff, and then show a little bit of our DICE solution. So DICE is it's a software platform that we have built a number of pieces of functionality in over the years. I'll give a little bit of a live demo and kind of describe what we're talking about, but at its core, we have real-time data on devices and up-to-date information on purchases. We have direct API access to sort of build into whatever, either be your asset management system or feed into your asset management system. An easy-to-use task-oriented interface. So if you're a procurement person versus a help desk person, you're going to be able to find a view that gets you what you need, as well as being able to export information quickly. If you just need a spreadsheet and need to hack against a spreadsheet, we have a thing for that. Asset management, in this case, really is an iceberg, right? So the first part of edge computing is, what do you have? How are you getting it? How do you know what you have in the field? You have to be able to keep track of this stuff over time. So I see it as this little piece above the water of, what kind of devices do I have? Underneath that, we have in-depth hardware information. I need to know, is this hardware going to work for this next solution I'm looking at? Is there a spare capacity in this platform for what people want me to run? Are these active? Are these assets active? Where are they physically? Do we actually know, how many have been lost and stolen, maybe turned off? We've had, in my, sort of past life, we had a number of situations where hardware was turned off because it was seen as inessential. It wasn't labeled. It didn't look like computes. Maybe somebody unplugged it because they thought, oh, it's just a pointless box corporate sent us. So it gets unplugged. It's not on. How do we track that? And then, towards the end of that life cycle, we're making hardware rotation decisions. Can we make this platform work another year? Can we make it work another 2 years? When does the warranty end? And, sort of how many systems I need to replace these systems that exist that I need to replace next year. It folds into maybe, I don't want to overbuy or I don't want to underbuy. We've seen supply chains stretched almost to the breaking point over the last year and a half for various reasons. And those supply chains mean planning is ever more important because you can't just go out and get another 500 units if you need them. You do need to do some planning. DICE brings to the table here is progressively giving deeper insight into the devices. We sort of start with that first step of procurement time hardware information, which is DICE. We also have DICE Plus, which is real-time hardware information, which feeds into the sort of how much spareness do I have in the platform? What's that device actually look like? If somebody calls and has an issue, when's the last time I saw it? What's it doing? And then DICE Complete, which is full interactive device management. I'm going to do some demo here. I'm going to swap to a web browser. One moment. So you should be able to see my screen at this point. And this is a basic device view in DICE. So We're looking at a system that went through our manufacturing facility. We collect, some, low hundreds of data points on the device, correlate that with with the order information from our ERP system, and present that to you in a format that you can take a look at, search, sort, export as necessary. These are Acme Corporation devices. They're a little bit mocked up, but we can see the processor, memory capacity, manufacturer information, all the way down to firmware revision of the SSD. All of this sort of feeds into a sort of a help desk oriented view in some cases. So somebody calls me, I want to know, hey, I heard there's an issue with a particular firmware revision of SSD. Do you have that? What capacity SSDs did we buy on the system? When did we buy this system? When we bought it, when was it invoiced? Where was it shipped to? Right. We also have the ability to create a ticket here. So if the device had an issue, I could create a ticket. It's automatically going to fill that device information out, and we'll be able to submit that and get an RMA very quickly. We also have an order-centric view. So if you're like a purchaser trying to get information on, what kind of orders I've made in the past and want to look at my devices from an order standpoint, that is also possible here. So I can click here and see all the devices that came in under that order, and then again, drill down deeper into those devices themselves. Here's the order information, so where it was shipped to. If it's been repaired before, it would show up here. These would be clickable tracking numbers for FedEx and UPS, as well as billing information. So the idea here is to give you sort of a view into the procurement process as it happens, sort of sliding into what does that maintenance and repair look like. But first, we're going to go through some configurator stuff. So in one moment. Oops. My apologies. There we go. So we've getting past the procurement stage. We want to see, we've seen what we've been ordering. We kind of see what it looks like. We've seen what the hardware configuration came when we bought it, where it got shipped to. Typically, the next step would be sort of that imaging and deployment stage. The first thing I wanted to highlight here is image build. When we're talking about edge computing devices, what we want to see in a platform is uniformity in imaging. How we do that is by automating the image build process. We actually script everything that goes into an image, including the first boot processes, and actually build that into a task sequence that's a repeatable, testable thing. Then means we can change control it and sort of customize the OS to work exactly like you need it to, and then deliver that on a monthly, quarterly basis as patching or whatnot needs to happen. We also use another tool called configurator. Configurator was born out of a number of frustrations with the out-of-box experience in Windows 7 as well as Windows 10. And also the need to have sort of testable field deployment. So when you look at configurator, we're seeing a simple automation tool to reduce complexity at the end, right? So in the field is when you don't want to have complexity. It's when things could go wrong, and obviously when you want to have a testable and repeatable process. It also provides a linear Windows 10 out-of-box experience, since Windows 10 has an out-of-box experience that's suboptimal for a lot of digital signage, edge computing work experiences. It's just something a little bit better. So what we're doing here is providing a difference between a monolithic image where we're having the config pulled off and applied later. So we're still building an image. There may be software built into the image, some configuration built in the image, but the differences that you might have where, for example, in an edge computing context, we might have something that needs a particular Kubernetes package or some kind of container workload deployed to it via command line, or we need to install, change the networking setting slightly or display setting. we'd able to actually put those and build that on the web, get a 6-digit ID, and then enter it into the system during the deploy time. We can set up multiple configurations. So if we have, like, in the case of video, vertical orientation and horizontal orientation displays, be able to have those be separate configurator configurations. I actually have that up, so I'm just going to swap here. So when we look at configurator in the web, what we're really doing is setting all these settings and then getting an ID, right? So we start with things like computer name, where we support some computer naming standards, like we can use the serial number or the MAC address to be part of a name. We can do domain join if necessary. Network setup, typically wireless would be what people are looking for. So we can, preload a WPA to pre-shared key into the device so that when it connects to wireless network, it has the credentials for that. We can set the audio configuration. So in this case, I want it at 60% volume. We set that. Screen mode is another setting that becomes difficult in the field, where we might want to, say, extend the displays, and we want to set 2 displays. Maybe they're both 4K displays, portrait, and this one's actually to the right of or above or below the other display, right? So also make this a 4K display in landscape mode. So now we have a screen configuration that'll get applied to the system the same every time, instead of having to hunt and pack through multiple menus. If we look at our security tab, we can set up an auto login. Typically, we'd put that in an image, but if you have a need for multiple auto logins, depending on like a building or a store, that could be possible here. We can do wallpaper, auto hide taskbar, as well as what I call the escape valve, which is PowerShell script, where we can put a PowerShell script in that's run under the system context. That lets you really do things like install software, or like management agents, report back that a deployment successfully happened, or even retrieve information necessary for that installation. For example, query my network adapter, get my gateway, and then get some information that's specific to my location based on that gateway, like a naming standard or something else that's implemented via PowerShell, right? We're also able to do shell replacement in the case of like a internet kiosk. We could do like a UWP browser here type idea, setting time zone, NTP, and Windows updates. So we can set some, if you want to be able to put a WSUS server in the image as well. So once I click submit here, we get a 6-digit ID that we can apply to multiple systems, test ahead of time, and then provide the simplest of instructions in the field to people to be able to sort of deploy these types of computing devices. I have this up on a system, so I'm going to pull up, I think this one. Let's see. So show configurator here. I'm using a piece of software here, calling it, well, this is Dice Complete. It's our customer technology preview. So it's an idea of what that interface would look like for a customer. We have a lot of the underlying technology done, but we're still working on the UI. So I have, a list of PCs that are essentially in my demo environment here. And I'm able to do a few things here. In this case, I'm going to use the RDP functionality in an iframe here to get to a remote PC. This PC is about 15, 20 miles away from here. So this is, sort of what a, connection through the internet will look like. In the configurator case, I should also mention there's a device behind me running configurator, more of an out-of-box experience. So see a black screen with just a window open. Simulating that here, when configurator starts, we can obviously put in the 6-digit ID. If we don't put an ID in, we're able to do some further configuration as well, like up to 18 screens that are configurable here. This one's configured only to pull the ID. So all those settings you saw on the web, we'd be able to also either remove or have in the out-of-box experience here. Typically, our customers are using machine name and time zone. So the computer boots up, I see the out-of-box experience, I don't see any Windows desktop or anything else, and it asks me for the machine name, time zone, finish. Really giving that task-oriented interface to your installers to sort of just do the one thing that's necessary and kind of go on with it. Just going to swap back here to our presentation. Oop. Okay. So image sync is another solution we use in the field on our edge compute. This is actually, when I talk about a platform, we really want our customers to use our platforms to build their solution, right? But clearly that doesn't, sometimes we're a little ahead of the curve. Sometimes, we're going on the same journey you are. And ImageSync is one of those solutions that we built on our edge computing platform to focus on field reimaging pain points, right? So we saw an issue there. We saw that we had some edge computing stuff coming out, and we built ImageSync on that edge computing hardware on that platform so that we had a break fix point in the field for field reimaging. So ImageSync itself is a small appliance, typically this middle box here, or a 1U or a 2U system. And it securely and reliably transfers images to and from Now Micro or another ImageSync appliance that you have. And it's a simple 2 to 3 click imaging interface and also creates USB sticks for you. So this is an example of it, the platform's important here, right? Because if you had no hardware out in the field to do this, this might be an expensive proposition. But if you already have the hardware out in the field to do, for example, sensor management or video analytics or something like that, having also a point where field technicians could reimage PCs in the field, for example, in combination with Intel vPro technology, is valuable here. So my typical demo that I do for this is I would remote into a system, I'd reboot it to Pixie, and I'd reimage it with ImageSync, right? Having a little, trying to mix it up a little bit and not do the same thing I've done before. So I actually just have the UI on here to show what that looks like. So we're going to go back to our system that's many miles away and show the ImageSync GUI. So imagine I rebooted this PC to, it's a remote break fix scenario. Somebody calls and says, oh man, that computer's broken. And I think it might be a reimage issue. I did a little bit of triage. It looks like it's broken. So I can go to that system, reboot to Pixie. Because I have an ImageSync appliance out in the field as an edge computing platform, it Pixie boots to WinPE, and I'm presented with this UI that gives me a list of images it can only show images maybe that are compatible with my device, or in this case, I'm showing a lot of different images. And I can click on an image, click reimage, in about 5 to 10 minutes, depending on the image size, it's going to reboot and be back to normal. I actually use this for a lot of my demos. So you see this sign, I don't know if you can read this, but it says sign 1.0. It's actually a demo I built in 2018, it looks like, that was used for a couple conferences that we went to, and we're demoing vPro technology. So I was able to actually take those images and capture them, and anytime I need that environment, I can deploy them back out. And within basically a couple dozen minutes here, or a dozen minutes, I'm capable of reproducing that demo. I also even have, I think, one of the ImageSync, like a server image on here as well. So long story short, ImageSync is one of those sort of pain point type solutions that we built on top of our edge computing platform. With the combination of Intel vPro, it allows us to field reimage systems very quickly. Another piece of a platform obviously is, sort of that repairability. I'm going to go back to the presentation here. Okay, apologize, keep on clicking on the wrong button. So I mentioned Intel vPro. That's a pivotal technology for us, especially at the edge. I have some hardware slides and a couple slides here. But essentially what we're doing is most of our systems we recommend for the edge computing have Intel vPro. It lets us do a lot that you could not do without it. Without physical access, we can do hard resets, we can power on, we can connect virtual devices and root to Pixie. So if I have an Intel vPro enabled fleet of devices, and in fact, all of these devices that are here, except for this one, are Intel vPro enabled, I'm actually able to re-image any of these PCs as long as they have a power connection and essentially a network connection. I'm able to remotely get to these PCs without an operable operating system and get them back going again. It's a powerful combination when you look at things like image sync. Our NUC cluster, which we'll talk a little bit later about, that image sync, image can run on that platform and be used to also re-image those systems inside that box. It also gives us that remote triage capability. So with Intel AMT, I'm able to see exactly what's coming out of the back of the HDMI port. So I can quickly triage between display issue versus device issue, right? I know that I'm outputting a signal, but nothing. They say the screen's black. Well, let's turn on the screen first. Let's make sure it's plugged in. Be able, or maybe I know who to roll, right? I need to roll the display guy, not the device guy. For that work. Or in the case of triage in a first call resolution context, somebody calls, they say they have a black screen. I can see with Intel vPro that this system is not responding at all. I think it's actually completely dead. Maybe the power supply died or something else that's fairly significant issue. I was able to fix it. It blue screened, and I'm able to reboot it and do a hard reset and get it back up. The difference there is while I was on the call with the customer, I wasn't trying to diagnose maybe too much, right? I didn't have to have them do anything necessarily. I reached out remotely, integrated that unit, and I increased the first call resolution because all the things that are just reset the box or turn on the monitor or whatnot can be dealt with on the call. And the things that are actually pivotal and important, then I do the truck roll, then I have somebody pull the system and send it to me, right? So we're sort of triaging and also increasing success rate, which, reducing truck rolls does save money. So I went through a number of sort of solution blocks, right? We talked about a platform, what a platform means, what we've built upon the platform, and the pieces that we think a platform should have, right? So we're talking about configured, reliable, and manageable devices on the edge, right? We talked about image build. We talked about dice, the single pane of glass to now micro. We talked about configurator for field customization, image sync for application of system images, Intel vPro for that hardware level control. And then, obviously, services are typically a fairly big piece of that. I'm gonna shoot back over to my web browser for one more moment and show a couple other items in this Dice Complete CTP here. When vPro is active, this demo actually does not have Intel vPro enablement right now. I messed up my network config last night for this piece of particular infrastructure. But we'd be able to do a hardware connect here and connect to that vPro and see exactly what's happening on the system. We'd be able to perform some actions like reset, so on and so forth. I also have a file view that's pretty interesting here. So in this case, this is actually a Linux machine. So this is an Ubuntu VM where I can actually remotely interrogate that file system just to show what that looks like here. Here's the Ubuntu screen. I also have a MacBook, but not our usual edge computing hardware, but we have the capability of doing some remote interrogation. This is a MacBook that's sitting quite a bit away from here. I'm not able to, I guess I'm not able to type a password in too cleanly, so I'll just cease and desist on that. And then this is actually a Raspberry Pi device. So I said I'd talk about icebergs, and I did have the iceberg slide in there, so I think I fulfilled that. I'm just going to connect again. Raspberry Pis are a little bit slower than you expect most of the time. I'm going to send it a key so it wakes up. well, I've loaded a web page here for the OpenVINO site. Oh, there we go. So I have OpenVINO website open on this Raspberry Pi that's, again, physically distant from where I am here currently. So just show you some capabilities here with a file system access, and then I also just have in a remote window here a terminal connection. So I think the other idea here as we talk about edge computing and how to sort of manage these devices in the field is what can you do without visible action on the user side, right? So I'm looking at a digital signage system, I'm looking at an edge computing device, maybe it doesn't have a display connected. I can't trust somebody to, have a mouse and keyboard there. I need to be able to do things like get to an interactive device, a prompt behind the scene, either on any OS, right? So this works on Windows, Mac OS, and Linux, or maybe I need to get to that remote file system, behind the system in order to sort of upload a file to be able to run it from the command line, right? So we have some capabilities there that I think are important to sort of keep the man behind the curtain, if you will. So go back to our slides here. So, edge computing hardware. Hopefully, I don't always like talking about speeds and feeds, but clearly the hardware is a big piece of edge computing, right? And being, having the capacity for a platform and being future looking. So I talked about some of the attributes that we expect edge computing hardware to typically have. Hardware level control with Intel vPro is one of the things that we build a lot of functionality around, and I think you should as well. Flexible form factors and performance levels. So if we look at, there's a variety of hardware here from Celeron all up to Xeon, even a 5-system cluster. These form factors need to be flexible in the idea that your requirements are going to be different. You might need to be rack mounted. You might need to be mounted behind a display. You might have a kiosk that you're fitting this into. It's necessary to have some flexibility in form factor and performance levels to meet your particular needs. If you're doing video analytics, your CPU requirements and GPU requirements are probably going to be different than a sensor-based workload. So accelerator options is another one we typically would look for. So being able to put, there's a number of accelerated devices if you're using the OpenVINO toolkit, for example, whether it be FPGA or the USB sticks with the neural compute type things. There are accelerator options. These devices fit various form factors and things of it, but you typically want to see some options for that, as well as OS and stack flexibility. So the cluster here I actually have running Docker Swarm with Portainer doing the management for it. And I forget what I have, like an Nginx proxy manager container as well. So I'm able to sort of deploy a website to this on one of the Linux boxes and then pipe it out via the Nginx instance to sort of a user accessible or other machine accessible website or a number of services. A lot of our systems run Windows, right, as well. Windows also has a container story as well as a lot of sort of flexibility in the AI field, with the associated Azure services and some of their management as well. So, we're typically looking for having options for Ubuntu Linux or Clear Linux, as well as Windows, in particular Windows IoT Enterprise, which has a number of advantages from a licensing cost and usability standpoint over like a Pro or Enterprise, or Pro in particular license. So we're just looking for some flexibility, right? Can it run your stack? If you're a Kubernetes shop, we want to be able to run Kubernetes on a cluster. If you're a Docker Swarm shop, we want to be able to run Docker Swarm. If you're just using VMs, all of these systems will be able to run VMs. I not necessarily want to run it on the Celeron, but there are options. And typically architecturally, I have this slide from our, we released the visual data devices a couple years ago, and that was our first sort of edge computing talking point, right? Was this standard that necessitated a number of attributes, most of which I talked about in the previous slide here. But you're really looking at being able to move that workload to the part where it's supposed to be. So if we're doing video analytics, transcoding, or caching, having it just inside the premise enables you to save money, in particular on cloud compute, right? So every video frame that goes up, you don't want to send to the cloud for some kind of analysis, right? Every sensor reading, it might need to be consolidated, right? The temperature's been the same for the last 24 hours. Maybe that's more of a pulse point than it is sending a huge data feed, with 100 temperature reads a second, right? Only send the delta or the changes. So we're looking at an optimized platform for edge compute, and it typically looks like this. Whatever that workload looks like, it's sitting on a platform that's on the inside of the user-facing devices, but on the inside of the premise facing the cloud as well. Obviously, people do run some of these workloads on device as well. So, video analytics in particular. There's some other use cases where people use the excess capacity on the user-facing device to run their workload. That's not a bad idea in all cases, but being able to have one or more systems dedicated to edge compute gives you another place. And again, that sort of platform idea where maybe these edge systems that are user-facing, running the digital signage last a couple of years longer because they're also not doing these other workloads. I've consolidated this workload intelligently, saved costs doing that initially, and also extended the lifetime of at least part of the solution. So, talking brass tacks here. First system I have here is the DPM7 CCH, which is our, this is probably not a typical edge compute type solution. This would be more of a user-based facing solution. So this can run up to like 4K digital signage, for example. Well, it's really right-sized, right? Because it probably doesn't have a lot of overhead to do a lot of analytics workloads or other edge compute workloads, but combined with something, doing some heavy lifting behind it, now you have a cost-optimized solution. And I just wanted to show that. It's one of our newer systems. Pretty neat. We also look at some of the stuff Intel's been doing, innovation in form factor with the NUC Elements line. So this is a NUC Elements system. It's a fanless chassis. And by opening this up, we're able to put a number of different boards in this. There's actually 7 different compute boards we can put in here with and without vPro all the way up to i7. So we have that flexibility in the workload. We have this one form factor, right? So maybe it's one kiosk I need to design, maybe one mount point behind the display, but now I can pick a different level of performance depending on what I'm doing with that workload. And I can also, maybe use something like this to drive the computation that something like this requires with an i7. So looking at platform flexibility, our newest system would be the DPM7 Cluster. This is on display here, obviously, as well as on the screen. And we can put up to 5 NUC boards in this device. We optimize the airflow significantly so I can run very cool. In this case, I actually have these externally networked along with an additional dongle to sort of a gateway. And they're actually, the top device is actually, well, they're all, 3 of them are running Docker Swarm. The rest of them are all running Kubernetes, actually K3s with some Nginx stuff on the top, as well as its own DHCP server and some reimaging services as well. So let's talk about a self-contained piece of hardware that has 20 cores, right? So each one of these devices has 4 cores. So we were talking about 20 cores, up to 32 gigs of bytes of RAM per device. We actually have some pretty dense computation here to be able to drive some of these workloads. We showed this off a little bit way earlier in the year, last time I traveled, and got a lot of good feedback around it. And I think driving these sort of form factors and having sort of a modular type idea where you could have 1 device or 5 devices here, and sort of forces you to think about that sort of swarm or coordinated computation in the case of like a Docker Swarm or Kubernetes cluster is really future facing. I think we're going to see a lot more of this kind of compute and compute form factors where I can sort of scale up with some kind of hardware that I put in there over time, and we'll see a lot more of that in the future. We also do rack mount options for edge compute. At some point with small form factor systems, you only can get so much heat in them. You only dissipate so much. Then we start usually talking about a 2U or 4U type system. Our 4U system actually goes all the way up to 28 Xeon cores, and obviously significant amounts of memory, and can fit up to four 16 by 16x PCIe adapters. So whether that be like quadro adapters for some kind of workload and AI workload, especially the video analytics or driving video walls, the hardware ends up looking fairly similar. So we have these sort of airflow optimized heavy hitters that really have that I/O expansibility capability, right? So you could put an accelerator adapter in here, you could put FPGA board in here, you could put piles of GPUs and pump a lot of heat through this and be able to power a lot of workloads from smaller systems or IP cameras or so on and so forth. So just to sort of wrap this all up, today we talked about edge compute, what it looks like, sort of interweaved a lot of software in this, and I get that. That might be a little rough for some people, but realistically, we're talking about platforms, right? It can't just be about the hardware. It can't just be about the software. It has to be about the package, the thing that you deploy today that drives your use cases into the future. And I hope I gave you a taste for how we see edge computing, how we want to support edge computing and compute in general, on premise, and enable those sort of, platform innovations over time, recognizing essentially that we probably don't know what we're walking into. We probably don't know what 5 years from now, what the new thing necessarily is. It might be any one of these sort of things I talked about today, but we want to be able to plan and be adaptable for it when we meet it. So thank you. I'm gonna look here to see if there's any questions. Looks like there's no questions right now. I normally have like a slide with like, follow me on Twitter and, things like that. I don't today. So, but if you want to, feel free to reach out to me, bernardc@nowmaker.com, or obviously visit us at nowmaker.com and nowmakerplayers.com and get more information. Definitely willing to, field any questions and, talk further about edge computing and how we can help you make your dreams happen and build your applications on your platform. So thank you.